In the previous example, we've looked at horizontal asymptotes and how to determine them by letting x approach infinity. In the next coming examples, we're going to look at how to determine infinite limits. Infinite limits are a result of when you let x approach a number, and then the output is either infinity or negative infinity. As we've seen in previous examples, a limit cannot equal infinity. However, a right-hand limit or a left-hand limit can. So if the limit of f as x approaches a gets increasingly large without bound, we say that f of x goes to infinity. An example of this is the graph of 1 over x. In the graph of 1 over x, we see that as we approach 0 from the right, the y value goes to infinity. As we approach 0 from the left, the y value goes to negative infinity. We say that the line x equals 0 is a vertical asymptote. We say this because there is no y value that x actually equates to when x equals 0. The line x equals a is a vertical asymptote of the graph of f is either the limit as x approaches a from the right of f of x is equal to infinity or negative infinity, or the limit as x approaches a from the left of f of x is equal to plus or minus infinity. What this means is if you approach an x value from the left or the right, and it ever becomes infinity or negative infinity, this is what we call a vertical asymptote. In example 4, we're going to look at how to find a vertical asymptote. So we're going to find the vertical asymptote of the graph f of x equals 1 over x squared. So the first step in this problem is to simply graph this. So I suggest you take a second on your calculator and actually graph this out. Alright, now that we have a nice graph of this, we're going to look at how to determine where there is a vertical asymptote. So you see that as we approach 0 from the left, it looks like the graph is going up towards infinity. So we write that as the limit as x approaches 0 from the left of f of x, and this is where f of x is equal to 1 over x squared. We get that this is equal to infinity. And again, that's because as you approach this graph this way, the y values are going up towards infinity. And the limit as x approaches 0 from the right of f of x, you also get infinity. That's because as we approach from the right, and if we follow those y values, you see how we go up towards infinity. So again, those y values are going up towards infinity. So 1 over x squared approaches infinity. So just to be clear, this is x as you approach from the right, and this one is as x approaches 0 from the left. An important side note to make is that based off these limits, we get that the limit as x approaches 0 of f of x should be infinity, because both of these limits are infinity. However, this is not true. The limit does not exist because an actual limit, not from the right or left, has to be a number. So based off this observation that the limit from the right and the limit from the left is infinity, we can deduce that the line x equals 0 is a vertical asymptote of this graph. And you can look at a table on a calculator to determine this as well. As you get insanely close to 0, your y values are going to jet rocket to infinity. Now, they don't both have to be infinity. Only one of them does. So if this ended up being negative infinity, then you would also have a vertical asymptote at x equals 0. Alright, on your own, I want you to try to determine the vertical asymptotes of 1 over x squared minus 4. If you don't know what to do, I recommend simplifying and finding the vertical asymptotes algebraically like we did in Algebra 2, and then you can use limits once you kind of know what you have to work towards. But step 1 is to always graph it, and I suggest graphing in the standard window first. Alright, so here it is graphed, and just by looking at this, it looks like we're going to have an asymptote here at x equals 2. It also looks like we're going to have an asymptote here at x equals negative 2. So then we're going to observe that the limit as x approaches 2 from the right of f of x, we get infinity. So again, that's this limit right here as we approach 2 from the right. And if we approach the limit as we approach 2 from the left of f of x, we're going to get negative infinity. If we approach 2 from the left, that's going to be in this direction. So this is x approaches 2 from the left. And so you can see how we get positive infinity or negative infinity. So either way, this makes a vertical asymptote. So let's try to find another one. So it looks like we're going to have one right here at negative 2. So the limit as x approaches negative 2 from the right, it's going to be this one right here. As x approaches negative 2 from the right, the limit of f of x is equal to negative infinity. This right away is enough to tell me that we have a vertical asymptote. The one from the left does not also need to equal negative infinity. You really only need to check one. So then we get that x equals negative 2 and x equals 2 are vertical asymptotes. And this is because the limit from the right or the left equals infinity or negative infinity. It doesn't matter if it's positive or negative infinity, and it doesn't matter if it's the right or left limit. It's nice and convenient that they both work, but you just need one.